Hi everyone, I hope you all are fine. This particular tutorial में हम सीखेंगे what is imbalanced learning or imbalanced data handling. Actually, जब कभी भी हम if we are applying machine learning or data mining techniques on a certain data set, right? After knowing the data set, we become able either we need to apply balanced learning or not, or either do we need to balance our data set or not. Uh, for this purpose, how can we know our data set is balanced or not? For example, we take a scenario in which we have a data set in a CSV form and say it's a binary classification problem in which outcome class or class variable is in the form of like yes or no, right? Or in other words, it can also be like positive or negative, fine. Uh, what else can be any scenario can be yes or no, positive or negative, true or false, right? For example, fraud detection data set, ठीक है? Like yes, either the person did attempts for fraud or not, ठीक है? Either the person have a particular disease or not. तो इस तरह के अगर डेटा सेट्स हों लाइक जो बाइनरी डेटा सेट है नॉट ओनली रिस्ट्रिक्टेड टू लाइक ओनली बाइनरी डेटा सेट इट कैन आल्सो बी move forward towards multiple class variable data set, right? For example, where we have labels like 3 4 or like so on categories, right? Okay, for example, we have to binary classification problem in which class variable is in form of like yes or no, 0 or 1, or positive or negative, blah, blah. But for example, the positive instances in a data set are or vice versa. For example, positive instances are like say there are 80% of the instances that belongs to positive class and 20% instances that belongs to negative class. Or we can say 90% of the instances belong to one class and 10% instances of belongs to other class. In other words, we can say more of the instances, majority of the instances belongs to one class and minority of the instances belong to other class. Or if we talk about ternary classification problem or quaternary, where we have 3 4 or 5 categories, the same criteria hold over there as well. Say we have some instances either in positive or negative class and that belongs to majority of the instances, and rest other class belongs to minority of the instances. For example, we have a data set in which there are total thousands instances, right? And in which 900 belongs to positive class and 100 belong to negative class or vice versa. So point is where we have majority of the instances from the total instances, that particular class, either it is positive or negative, yes or no, true or false, 0 or 1, that would be considered as majority class. And those in which we have fewer instances, like either it is negative, 0, no, false, whatever the class is, right? Where we have instances minority in few amounts, right? We can say it's a minority class instance. So there are said like two types of actually class labels, like minority class labels and majority class labels. For example, if we have a data set like say here, this class belongs to a majority. Sorry, this class belongs to majority class instances, right? These instances, majority class, sorry, minority, and here it is majority class. We can say maybe it's a 0 and it belongs to 1, or it also can be like vice versa, 1 or 0, yes or no, positive or negative, blah blah. If we have data set like this, say not only limited to 20% or 10%, if for example there is 25% instances in one class and 75 instances in another class, again the data set is imbalanced, not a balanced data set. Even though one third of the instances belong to one class and two of the portion belongs to other class. For example, 33% instances belongs to one class and 66 or 67% instances belongs to other class. Again, the data is imbalanced. So in that scenario, if we have a data like imbalanced data set, then we need to apply imbalanced data handling techniques, or we can say imbalanced learning techniques. They are majorly like we have three different types of imbalanced learning techniques. Again, all the three falls in two actually types, where one is like undersampling and other is oversampling. When we do undersampling, for example, or what the undersampling means is, for example, we have a regional data set where here it is like minority instances and these belongs to majority of the instances. If we talk about undersampling, undersampling is responsible to decrease the majority class instances equal to the minority class instances. These instances reduces like exactly equal to the minority class instances. This concept, the scenario where we decrease the instances from majority, right, to minority class, this concept is known as undersampling. And what about oversampling? Say we have a regional dataset like this, in which here it is majority class instance, and this belongs to minority classes. In if we talk about oversampling, oversampling is responsible to increase the instances of a minority class exactly equal to the majority class. See, we can see it, right? The minority class instance is boosted equal to the majority class. Uh, Actually, what would be done to increase the instances? It will create some copies or some duplicate records, not exactly as like copies of the instances, but somehow it will take different certain values from each feature, whatever the features are belonging to a range. From that range, the algorithm takes some values and boost the instances or creates a duplicate or copies of the minority class instances so that it becomes equal to the majority class instances. So majorly there are two like concepts to balance the data set. One is undersampling and other is oversampling. Or where do we need to apply undersampling and when we need to apply oversampling? Say one of the answer can be like, for example, we have a data set where in which uh, overall total instances are already in a minority, a short data set, say, not too large data set. For example, we have only 300 instances in the data set or 500 instances in the data set, or similarly, we can say 1,000 instances in a data set, which is kind of a short data set. On the other hand, we have a data set like in instances in number of lakhs, say 5 lakhs, say 10 lakhs, say 15 lakh or 20 lakhs, right? For example, if we have a already short data set, and if we decrease, we undersample the data set, again, say we have 1,000 instances, 100 is here and 900 is here, or in other words, we can say, or like 20% if we minority class, then definitely 200 would be here and here would be like 800. And if we decrease, if we do undersampling, definitely the number of instances the data set will further decreased. Like already it was a short data set and we applied undersampling, it will result in further fewer or smaller data set, right? And so if we have a short data set, then best is to apply oversampling so that the number of instances increased further, right? the dataset somehow would be enlarged in case of hundreds oversampling. Like if we have 1,000 instances, these 200 would be increased. If it belongs to 800 instances are here in majority class and 200 are here. So these two would be increased up to 800, 8 and 8 would be 1600. Dataset instance would be increased. It becomes slightly greater than the original one. So number of instances somehow would be increased. How? Yes, what if we have dataset in instances in number of lakhs, then we can do undersampling so that uh, on one hand we have 800 or 9, 8 lakhs or 9 lakhs instances in majority and 1 or 2 lakhs in minority. Then definitely if we undersample the instances, it would result in 1 and 1 2 lakh or 2 or 2 4 lakhs. So one answer can be one option can be like this. For example, if when we need to apply undersampling or when we need to apply oversampling. So this can be a simple answer depending on the size of the data set, right? Okay. What else is here? The data imbalance data handling techniques that we have first is the data level method, second is the algorithmic level method, and third is the combined or cost sensitive method. What data level method is responsible for? It again further consists of random oversampling and random undersampling, which we have discussed just now. Like includes oversampling, includes to maximum instance of minority class equal to the majority class, and undersampling is responsible to minimize instances of majority class equal to the minority class. This is a data level method, and we have a variety of algorithms and data level method. Like we have SMOTE algorithm, synthetic minority oversampling technique, SMOTE, and some other are also like resampling and SMOTE and right. What about algorithmic level method? It's kind of a method which involves some algorithms. Say we have a random forest algorithm, and slight modification would be done in that algorithm. That method would be responsible for two types of things, like that would balance the dataset and uh, classify the dataset as well. Actually, random forest is a classification algorithm, right? And we will do some certain changes in the algorithm, in the classifier, in the classification algorithm, and that would actually balance the dataset and classify the dataset or train the model as well, right? So if we do certain things, if we do certain changes in the algorithm or in the classification techniques, then definitely then that model would be known as like algorithmic level method. And third is the combine or cost sensitive method, which is a combination of both of these, either to the data level or algorithmic level, or a combination of both. If we talk about it, then though that method would be considered as combined or cost sensitive method. It depends on the requirement, like what we need to what your requirement is, what your problem nature is, and what's your problem requirement is, or organization, or where you are working. It depends on the nature of the problem, what to do, right? For example, we have a problem where we need to compare some ensemble or the performance of some ensemble or non-ensemble classifier, or for example, we have to compare the performance of linear or non-linear classification models. On the other hand, the data is also imbalanced. Then we can do, we can go for data level method to balance the dataset, and rest is our own is our uh, selected somehow classifiers or classification methods, like for example ensemble, or as we need to perform a comparison of ensemble or non-ensemble classifier, or we need to compare linear versus non-linear classification model. So before that, we can say we will do the data level method to balance the data set, and after achieving a balanced data set, we can apply the classification techniques, either like the uh, ensemble or non-ensemble methods, or similarly linear or non-linear model, if we are going to compare the performance of two different types of classification models or classification algorithms, right? In that case, we can move towards like this. And for example, if we are not like doing a performance, or we are comparison, then yes, if we are going toward a simple, say, if we are only using ensemble classifiers or non-ensemble classifier, then we can do slight changes in the algorithm and move forward. And if we are doing a mixed kind of, we have a problem where we are doing mixed kind of like technique, using techniques like algorithmic or data level both, then we can say we are following the combined or cause sensitive method. So this was a theoretical concept and overview of the imbalanced learning or imbalanced data handling. Let's move forward towards applying data level method, which is like random oversampling technique, which we called it as like SMOTE, 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 that is a synthetic minority oversampling. Let's see how the code will work to oversample the instance. Well, here is the SMOTE algorithm, synthetic minority oversampling technique, which is an imbalanced learning algorithm or technique, right? It is actually like we can say synthetic minority oversampling technique, right? Okay, what it we're done. Like initially, we have imports of libraries like pandas library, as we already know about it. Like it would be used to work on a CSV file to make data frames of that particular file. And secondly, we have import SMOTE algorithm from a library, imbalanced learn dot oversampling technique. It's actually imbalanced learn is a, you can say, online a library from where we are fetching. It's a class, and fetching we are further we are fetching. It's a package, and from that package we are fetching a particular oversampling method, and which is whose name is like SMOTE, and some other are also as well, like C sampling and SMOTE double EN or blah blah. We can use those two as well. For practice, we have right now we have selected SWOT, and here we have sklearn library. As we have already discussed about it, like sklearn is a online scikit-learn library from where there are libraries for classification, there are libraries for regression algorithm, clustering algorithm, feature selection algorithm, and model training or model selection algorithm. Even though performance evaluation matrix libraries are also there as well over sklearn, scikit-learn library. From that library, what we are, which method we are getting, like model selection, which one? The train test split method. Actually, this library is taken to distribute the instance of the dataset, like the input variables and output variable would be distributed into x and y input variable and output variable. And somehow after that, we have to split all the instances uh, into certain training or testing samples. So that's why this method is, this library is imported here. Next is this is the code to upload the file, like import files, uploaded file dot upload, or the file will be uploaded here in our section, right? Simple, it's very simple. For example, like this. It is like this. We can simply select the file, like what I have. Office, yeah. Here we have file this one. It's a diabetes dataset file that we are working so far in our regular sessions. Okay, the file would be selected here as 5_diabetes be processed, and it is read with the help of pandas frame pd dot read_csv. The file name is like this, and it is stored in our own decided variable like df data frame dot head is to print the first 5 records, and if we mention a certain value here, say 30, it will print the first 30 records, and by default it will print the 5 records. Here we can say we have class variable as well whose name is outcome. All these various features or variable are input variable, and this is the output variable whose value is in the form of yes and no. Well, next is we are distributing the data set, this data frame DF into input and output. Input variable or input features are stored in a variable X, capital X, and output variable is stored in small y. How it is working, like the data frame dot drop this column, or like you see its name is outcome. Whatever the feature name is, we can use here in a single quote dot drop this column, and rest of the feature would be saved here. And if here we are taking only the outcome variable, right? Df select this variable, this feature, and store into y variable. Okay. Here we are counting the actually values of the class variable. Df class variable name is like outcome dot count the values. Value underscore count function is used, and the values counted values will be stored in the label count variable, and we have to just print it. It is showing like there are 500 instances that belongs to no class and 268 instances belongs to yes class. Okay, which is showing like the data is somehow uh, imbalanced, right? If we have a data set like 80 to 20% ratio, 90 or 10% ratio, we can use. It's somehow 60 or 40% might be ratio is. So, but if the data is like 66 or 67% instances on one hand and 33% on other hand, then we can say data is imbalanced. So here, the data that is somehow already balanced. But yes, for understanding point of view, if we are, how can we apply the SMOTE algorithm? Just for the understanding, we are using this. Here, we uh, use the library whose name is like SMOTE. Now we are going to use it. SMOTE method or library is stored in this from library. This particular method is stored in insert this variables which is named as SMOTE, small letters. And what we are doing here, SMOTE dot fit underscore resample, fit underscore resample. It's a method that works for SMOTE algorithm, fit underscore example, whose parameters are like what we have to pass as a parameter. As a parameter, we have to pass the whole data set, like not in the form of like data frame whole, but yes, in by splitting in two ways, like input variable and output variable. These are passed here as a parameter to this function, which comes under SMOTE. First parameter is responsible to for getting input features, and second parameter for output feature. And this SMOTE will, what will the SMOTE will do? SMOTE algorithm will oversample, as its name is like the synthetic minority oversampling technique. Will oversample the instances of the minority class equal to the majority class, and the resampled instances would be stored in X input features resampled and output feature resampled. And if we concat both after getting the resampled instances, we are concating with the library pandas frame like pd.concat x resampled or y resampled and y resampled. Both are concated and stored in the new data frame. Previously, we have a DF, which contains the original dataset, and the resample dataset variable name is like data frame underscore resample. And if we see the first instance dot using dot head function, it is returning like this. It's just confirming that the resample instances are gained, and we can see the count of the variable values as well. DF resampled. Here, what we done, we calculated the values from original data frame, which was like here, like this. And now we are going to continue the instances of resample data set from class variable dot values counts and stored in label counts. Let's see, it is showing like 500 instances are in yes and 500 instances are in no. As we have minority instances, majority are 500 and minority are 268. So minority instances would be increased up to equal to the majority. The majority is 500. This would also be increased up to 500. As we can see here, it is done so easily. 500, 500. That set instance is somehow increased and data becomes equal and balanced data set now. Here we are just storing DF sample data set into a CSV file. Index equal false. It will result in like the CSV file would be generated where serial number would not be. We are not seeking for the serial number. If we do not use this very parameter, there would be a serial number that would count, that would show the count of the instances. We are not interested in that, so we use index equal false. So this will this is actually formatting this resample data set into a file, your CSV file whose name is like 9 underscore diabetes underscore SMOTE in this particular environment of collab. And next command is for code line is for like downloading that file. Files from this collab dot download which file in this name. And once we execute this statement, this will download the file in our download folder, and we can see how it will return. Like I have here, I have downloaded. Here it is, right. See, there are total 1,001. One is for this and rest are 1,000. So this was all. Uh, for the like to how we can apply the imbalanced learning techniques. This was actually an extra. This wasn't used in this code. Right? We have used. So you can also use SMOTE EN, SMOTE NC. These are the like borderline SMOTE can also be right. Resample as well. If we see resample of holy or resample, no, not here. Random oversampler. Anyways, there are certain techniques that can be used here, for the imbalanced learning technique. The purpose was is to what is imbalanced learning and how can we apply the balanced learning techniques. This was all for the imbalanced learning. Stay blessed. Allah Hafiz.